HTTP versus WebSocket. APIs are everywhere, from streaming your favorite cat videos to texting your crush, only to end up hitting the gym after being rejected. Underlyingly, this API uses different protocol for communication to the server. In today's video, you will learn about HTTP and WebSocket protocol and the difference between them. By the end of the video, you will be able to build a backend of a chat application using AWS. So, what is HTTP protocol? Remember when you always have to text first to your crush to get a reply from her? Yeah, that's HTTP. In HTTP, you would have to send a request to the server every time to get a response from it. So if you want a real-time update, continuous requests are made to the server, which is also known as polling. WebSocket, on the other hand, is like a relationship where both client and the server can send message anytime they want. WebSocket enables real-time connection between the client and the server. In WebSocket, you have to first initialize a connection via HTTP, then both sides can push message anytime they want until connection is not lost. It is used in chat application, gaming, and also while booking a cab through Uber. A video on that data pipeline soon. WebSocket make a connection to a single server, and until that connection is not disconnected, all the request and response will be handled by the same server. The disadvantage of WebSocket is that it occupies all the bandwidth of the server until it is not disconnected, which can also lead to server crash if too many requests are made from the client side. And that's why girl avoid needy boys. We will be using AWS for making our WebSocket API. AWS provides a service called API Gateway, which is perfect for creating APIs. Let's get started by searching for API Gateway and selecting it. Once you are in API Gateway, you will find a variety of API options that AWS offers. For our purpose, we'll choose WebSocket API. Let's name our API. We'll call it Simple Chat Application. Now the route selection expression is crucial because it determines how we'll pass our request. In our case, we'll pass our request inside request.body.action. Click Next. Now we have to configure routes. Think of API routes as a specific endpoint that identify different functionalities within the API. They are like the pathway that the user message take to reach their destinations. So we will be adding routes for default routes to connect and disconnect to server, as well as some custom routes for setting up user's name, sending private message to a specific user, and broadcasting message to all the users. Now let's integrate these routes using Lambda function. For that, we'll first create a Lambda function. So AWS Lambda is a serverless service that we'll use to script our logic. Setting up it is straightforward. Search for AWS Lambda, choose Python as the interpreter, name your Lambda function, hit enter, and your function is created. Now head over to API management service and integrate your routes. Typically in real world scenario, every route hit different Lambda function, but for this basic application, we'll consolidate into one function. Hit next again and your WebSocket will be created. On the left side, click on stages. Here you will find HTTP connection, which initialize a connection to the WebSocket server, and a WebSocket connection which users will use to connect to this WebSocket server. Now let's create our logic for the function. Within this setup, we'll be dealing with two main parameters, event and context. The event parameter will have the request of the body provided by the user, while the context will hold essential metadata concerning the function. Will extract crucial information from the event such as connection ID, which serves to uniquely identify each user, and a route key indicating the endpoint for which the request has been initiated. Furthermore, the event will include a body field containing the message body and other parameters. This body value is structured JSON, so we need to convert it into a Python dictionary. If the route key corresponds to connect, then we just need to return status code 200 indicating a successful connection. If the route key is set name, then we need to have a dictionary which will map a connection ID and the name. So we'll create a names dictionary and we'll add the key and value pair in set name. After that, we'll broadcast a message to all users announcing the new member's arrival. The implementation of send all function will follow later. Similarly, for send public message, we will have a send all function. Now, if the root key is send private message, the body will contain the intended recipient's username. So we can iterate over the names dictionary and find out the connection ID of the user which we want to send a message and call send one function. We will implement send one afterwards. Lastly, if the route key indicates disconnect, then we'll notify all the users that the individual has departed and remove them from our names dictionary. Now let's create send all and send one function. Initially, we'll import the Boto3 library. It is a Python package used to interact with various AWS services within the Lambda function. We'll initiate a client object for our API management gateway. And remember, as I mentioned earlier, to establish a WebSocket connection, we must undergo a HTTP handshake. So we'll grab our WebSocket HTTP endpoint and fed it as a parameter into our object. Within the send1 function, we'll utilize post to connection method requiring the connection ID and messages intended for the user. In sendAll function, we can just iterate over the connection ID which is stored in our names dictionary and call send1 function. Now in send1, we can just pass the list of our names and the message that the user want to send. And in send1 function, we can just pass the connection ID of the user which we want to send the message and the message that the user want to send. Now we just deploy our changes, and before testing, it is very important task to give this function permission to access API management gateway. So for that, go to configuration, go to role name, click on attach policies, search for API, and you will see Amazon API gateway invoke full access. Click on that and now you are good to go. Now for testing, you will find many platforms to test your WebSocket connection. Just copy your WebSocket URL and search for WebSocket testing on Chrome. Select any. I have selected WebSocket King. Paste the URL and hit connect. You can see the connection is successful. Now let's create multiple connection. Now this is the request that we want to make to our function. Set name is the route key and the name is inside the body, which will act as a parameter. Now you can see when the user is setting up his name, other user are receiving message that this user has joined the chat. Now suppose Shifu wants to convey message to Akash and Panda that they have to do the training ASAP. So now let's check send public message functionality. So you can see that Akash and Panda has both received the message from Shifu. Now Panda wants to send a message to Shifu privately that he will not be coming to the training. So he will invoke send private route and send that message to Shifu. As you can see, Panda has successfully sent that message to Shifu. Now hearing this, Shifu wants to disconnect from this chat. So Shifu can disconnect and Akash and Panda will receive the message that Shifu has disconnected.